Hello and welcome to the Clean Energy Pod, powered by SSE, your guide to the people and technologies delivering the clean energy revolution. On today's episode, we discuss the new UK government's mission of clean power by 2030. We're joined by Keith Bell, Professor of Electronics and Electrical Engineering at the University of Strathclyde and member of the UK government's Climate Change Committee, to find out if clean power by 2030 really is possible. Thank you very much for joining us on the Clean Energy Pod. Clean power by 2030, that's what the new UK government want to deliver. Just explain to everybody watching and listening what we mean by clean power.
Well, the main aim is to reduce the emissions associated with electricity production. So we could talk about the emissions intensity. So how many grams of CO2 equivalent per unit of energy production. So we would measure the energy in terms of, let's say, kilowatt hours or something, megawatt hours, whatever unit you want to use. So how many grams per kilowatt hour? And the idea is to get that down to close to zero. So there's a question there about how close is close enough, which maybe we'll come back and talk around a bit. But that's basically the aim. It's electricity production. It should be enough to meet our demand. So it's got to be, with some kind of caveats around it. Should be the emissions intensity of that as near to zero as we can practically get it.
And does that mean, as people might think, therefore we need to have a purely renewables electricity system if we need a clean power system?
No, it doesn't mean that, because there are different means of getting electricity without the greenhouse gas emissions, or at least not at the kind of, compare with vehicles, you might talk about tailpipe emissions. Because there's always sort of emissions also associated with the kind of the plants that you construct, in the concrete or the steel manufacture or something like that. So at least in terms of when it's actually generating, get down to zero. And so nuclear power would work in that kind of score. You could have a bit of a discussion about whether burning natural gas when you capture the CO2, is that good enough? Because you can't capture all of the CO2. Claims are made that could get between 90, 95% depending on the process. But it's not all of it. Is that good enough? But the mainstay will be renewables. So, wind, solar, but also hydropower, which is a renewable source of electricity as well.
So I suppose if we think of it, is clean power an actual thing then? I mean, do you think it's practically possible, or is it more an aspiration? And quite frankly, if we get to 98% reduction in emissions or whatever the number is, then that's essentially clean power.
So 98% or thereabouts is what the CCC came up with in some analysis that was commissioned from some consultants that was published a bit over a year ago. So that looked at 2030, 2035, 2040, and it did a kind of big optimization where it kind of took as given that it's still I think it's the government's targets, inherited from the previous government of 50 gigawatts of offshore wind by 2030, I think something like 70 gigawatts of solar PV by 2035. Certain amount of nuclear power. So took those as kind of part of the generation mix and then said, right, given all the costs of everything else, what else would you do? But also put in a carbon price, and actually quite a steep carbon price, and sort of see how does that drive the reduction of these emissions? And that got to about 98%, so just that last 2% from unabated gas. Is that close enough? Maybe in terms of the variability of the weather. So you could have a good wind year, we got, get excellent production. And then, you can do very well and do even better than that. But you want some kind of insurance policy in a way so that you can still meet demand, even when it's a less good windy year. So that you could do that via imports from our neighbours over the interconnectors. But you could do it by using the existing unabated gas-fired plant and the natural gas system, which is still in place. As the demand for that gas reduces, that infrastructure has to be paid for by a sort of smaller user base. But it's an asset that's still there. So, like I say, could form a sort of insurance policy.
Now, we've skipped ahead in this conversation essentially to what the power system could look like in 2030. Just compare what it looks like today in 2024 compared to what it would need to look like in 2030 in terms of proportion of renewables, how we ensure security of supply at the moment compared to how it should look in 2030, assuming that this target is met.
Yeah, so we'd probably get about half of our electricity from burning gas, and there's maybe about, I'm trying to remember all the numbers now, something like, 10 to 15% from nuclear power, and there's increasing amounts from wind. So what is that? Oh, it's probably about, who's keeping track of all these numbers I'm spouting out?
Or something.
Something like that. There's a small amount from a significant amount from biomass as well. And then again, increasing amounts from solar. And there's a certain amount of it that we import as well. So we'll be looking especially to substantially get rid of that unabated gas. So we might still be burning gas, provided we can capture and store the carbon. But as I said, we said earlier, there might still be a kind of 1 or 2% of unabated gas that just sort of tops up on the kind of these high demand days, if it happens to not be very windy on those days.
So we've talked a lot about generation there, which is the mix is obviously changing and more renewables, but also other technologies will probably need to be there from a security of supply perspective. The other point is the grid, because you're changing from a system based on, power stations in various parts of the country, feeding the whole of the nation, to the generation actually coming from offshore, if it is increasingly wind. What implications does that have for the grid and the build out of the grid, which we hear an awful lot about, especially from ministers who say, well, we need to build out quicker because it's a roadblock at the moment?
Absolutely. So, it's kind of obvious that you can't use the power if you can't get access to it. And offshore, there isn't any network, but it has to be built. There's nothing, you have to get into the onshore network. But although, the big challenge here is objections to building the onshore network. Because getting it to the beach is one thing, if you like. Getting it through to the demand centres, the big cities and every town and village in the country is another thing. And they are all onshore. So, we can't avoid reinforcement of the onshore network because the power's coming from different places in comparison with how it was designed and built, for over decades, actually. So that's a big challenge. Overhead lines are not popular. Okay, they're not
Are they
everywhere.
Necessary?
They are necessary, I think. The first thing would be how much are you prepared to pay for your network capacity? So there's a lot of the objectors will say, well, hey, put it underground. There are limits to how much you can put underground, partly due to the terrain. If you're kind of building over mountainous terrain, it's very difficult to bury it. You may be dealing with very shallow soil and getting into rock. You've got the crossings of rivers and so on, and steep kind of bends. The cables are not kind of good for that. Overhead lines actually work kind of better, actually, in terms of the kind of civil construction works. And there are electrical limits as well to how much AC, alternating current, very high voltage cable, underground cable that you can use. It causes all sorts of problems with managing voltages and kind of possibility of resonances on the system if you're handled very, very carefully. So you could go then to high voltage direct current, which is the type of technology that's used to connect Britain to other countries, to France, over to Ireland, to Belgium, the Netherlands, and so on. But these depend on big converter stations to convert between AC and DC. You think of the converters for your laptop or your phone or whatever, but these are huge, size of, a couple of football pitches or something like that. And they have certain kind of technical advantages in terms of flexibility, but also technical disadvantages in terms of the need to get the controls absolutely right, the behavior of things like network protection, but also it's just very expensive to build these big converter stations, albeit they can then let you use some cables. And if we go further offshore, for example, the big wind farms, let's say out the Dogger Bank or whatever, will be connected in using this high voltage DC technology. It becomes worth paying the big cost of the converters if it's far enough, because the kind of network losses are reduced and you save a bit on that. But for onshore undergrounding, that gets around some of these kind of electrical challenges, but it raises other challenges.
It's good, isn't it? But let me interrupt you for just 1 second. It's really important for algorithms and everything else that you can like, comment, or subscribe. It's not just to feed our ego, though that helps. It's also to help broaden the reach of this podcast. It's all about everybody learning as together we try and deliver the clean energy revolution.
And you've also got a challenge of just how many sections of cable you need. You need to put lots of lorries to carry them together. You've got joints to connect them together. These kind of are not trivial to do. Okay, there's the industry knows how to do it, but the more joints there are, the more possibilities of failures there are. And you've got to dig it up and repair it and put it back down again. So it's not a panacea, basically. Although feasible? Yes, more or less, but it would be a very different way of doing things and a much higher cost. And what's really the kind of degree of unacceptability or acceptability of an overhead line anyway? These things are not new debates. A friend came across some ads from Country Life.
I was going to say
in 1960.
It's not the first time that transmission infrastructure has been built in the UK.
Absolutely. So there's all these challenges, exactly the same kinds of objections back, 60 years ago. And it was very interesting seeing these ads and exactly how, in those days, this was down in England and Wales, the Central Electricity Generating Board was trying to get public support. And they were in a difficult position. The total cost of all of this being paid for by all electricity users versus, doing something to protect someone's visual amenity, the views from your backyard in a particular location. It's not easy. And then we have to take account as well of all sorts of other local environmental impacts, kind of biodiversity and all of that. So even if you come up with an outline design and you go for overhead lines, you've still got to do it in the right way, just as if you go for underground cable. You've got to do it in the right way.
But it is doable. It's just it's clearly a live public debate about what technology to use and what the costs are.
Yeah.
We've got a generation mix that's changing. We've got clearly an issue around ensuring that the network is there. The other bit in my head, which I think gets less attention, is the kind of flexibility point, which is if you have a system that relies upon wind and solar, well, we know that the sun doesn't always shine, the wind doesn't always blow. So how important is that flexibility and storage, and how different will that future system look to the one we have today?
So first thing to remember, I think, is that the system has always depended on flexibility, albeit we've tended to depend on flexibility of the generation side. So you're flexing the total generation, to match demand as it varies through a day and through the week, through the year. But as you say, the resource, it becomes a large part of the resources becomes highly variable. You can predict it reasonably well, a few hours ahead out to a day ahead. You've got a rough idea of how much energy you can get from it on an annual basis, but there's still variability and not always easy to predict. So, if we could get more flexibility on the demand side, so the demand kind of adapts, the time of use to fit when it's windy and sunny, that would help an awful lot. Although we'll still need flexibility on the generation side as well.
On that demand side then, so what does that mean in practical terms? Because we already have, big industrial users, for instance, will flex down demand and can be incentivized to do that. We've had some initial experiments or pilot schemes about individual households adjusting demand.
Yeah.
How much of a role does that play in the energy system in the future?
So I think in terms of reducing the kind of peak demand, or the peak difference between what's available from renewables and the demand, or residual demand, if you like, the gap you've got to fill, I think it can be very, very useful, especially when we've got a lot of electric vehicles, for example. So they've got a lot of flexibility, or in principle have a lot of flexibility.
Just big batteries, aren't they?
Yeah, batteries on wheels.
Sometimes, and sometimes they can provide so.
Absolutely, yeah. The challenge then is because they are on wheels, you're not always sure where they are.
Yeah.
And but the average car today, let's assume that EVs get used in the same way as combustion engine cars today. On average, a car is only kind of moving or away from not being parked 5% of the time. In other words, it's parked 95% of the time. So if it's parked and plugged in, then it looks like it offers a lot of flexibility, because the size of the battery, you don't need it to be charging for all of that time. The journey that it's made hasn't fully depleted the battery. And, you don't, even if it was fully depleted, you wouldn't need all those hours to fully charge it again, even on a slow charge. So you could do a lot with it, either by sort of pausing the charge or slowing it down, or, as you say, kind of drawing energy back out of the battery in order to kind of help with the system for some period of time, and then, put it back in again. That all adds up. So
to summarize then, essentially, we've got a rough idea what we mean by clean powered, which might not be, purely clean powered, but it's
getting close.
Getting very close to it. We know we need to have a lot more renewables. We need to upgrade the grid to kind of transport that. And we know there are various flexible ways of keeping the lights on when the wind doesn't blow and the sun doesn't shine. And there's things that actual households and businesses can do in terms of reducing demand and taking advantage of new technologies. So that all sounds very promising. But it's 2024. In fact, we're in the second half of 2024 just now. There's fewer than 2,000 days until 2030. Is clean power, however we defined it, is clean power by 2030 doable, do you think?
I think it is doable, but it's a big challenge. So really, really getting on with stuff, So we missed 1 year of building more offshore, well, at least getting new contracts for offshore wind. So we need to kind of get that moving again. I think it's good news that one of the first things the new government has said is they're going to remove the effective ban on onshore wind developments. There'll be various projects, hopefully, that can be dusted off and progressed. Getting on with sort of resolving those sort of planning issues coming up in respect to solar PV farms as well. So getting those resolved, to sort of reasonable satisfaction of local communities. From people I talk to say the money is there, the finance is there from big investors, large companies, SSE, ScottishPower, Ørsted, whoever, other companies as well, of course. But it's kind of mobilizing all of that. But maybe one of the kind of biggest challenges is around all the people who are going to deliver it. And it's across a huge number of different roles. So from, sort of technicians and craftspeople, project managers, environmental scientists who can do the surveys and assessments, even lawyers who are going to get all the contracts sorted out. Hey, at my university, we're short of lawyers to get contracts sorted. Professional engineers who can do a lot of the kind of design and analysis work and make sure it all hangs together. Yeah, we need more people, and that's something I'm very kind of aware of as an educator, among other things. Yeah.
So you think it is possible, which is that's kind of optimistic to hear. So
yes, I believe it's possible, but we've really got to push hard, and it needs a collective push, and we need to kind of make progress in resolving some of these sort of clear barriers, such as planning consents and how long that takes, contracting with the whole supply chain. We're a bit behind on some of the technologies in comparison with some of our European counterparts, with manufacturers of transformers, switchgear, cables, what have you. We've not got much time to waste.
Now, alongside being a professor, you're also on, the Climate Change Committee, which is set up by the UK government. Just explain to people what the CCC, as it's known, is, and what are you currently discussing?
So we were established as an independent advisor to government, established by an Act of Parliament in 2008. So it was an act in the UK Parliament. There was a similar act in the Scottish Parliament. So we're advisors actually to not just the UK government, but also the devolved administrations in Scotland, Wales and Northern Ireland. The main thing that we do is to define carbon budgets. So to give advice on what is a kind of a reasonable level of emissions that represents high ambition relative to our international obligations, the kind of Paris Agreement to reduce greenhouse gas emissions, that is nonetheless deliverable and feasible from a kind of social and economic point of view. So we're currently working on the 7th carbon budget to work out what that advice to government should be on the pathway to net zero. And that 7th period is 2038 to 2042. And we will report against what the existing budgets say.
I was going to say, so that's quite far into the future.
Yeah.
How are we doing, though, with the previous budgets? And how are we getting on? Because the feasibility of the later ones will depend on the action happening now.
Absolutely. So the first thing, relative to the previous budgets, it actually looks like we're doing well. But that's partly because those budgets were defined against an easier end objective, which was an 80% reduction of greenhouse gas emissions relative to 1990 levels by 2050. So now we have 100% reduction, get to net zero. So, there might still be some emissions, but we'll have to kind of offset them by some capturing of CO2. So the net result being zero. So yes, the first 3 budgets set against a slightly easier targets. We're doing all right, actually. And you think about where we've got to in comparison, our starting point, where we've got to relative to other large industrialized nations and where they started from, we have done really well. But we've got to do more. The next bit is increasingly difficult. And in terms of the policies to deliver these outcomes, our most recent annual report to the UK Parliament, which was published just a couple of weeks ago, actually, was saying that, it's roughly sort of, I don't know, roughly speaking, we can see about a third of the emissions we've got to achieve in the next wee while, having policies defined we feel reasonably confident of delivering. Yeah, there are some big challenges there.
So we've got some new ministers in the UK government, new party, obviously. What would be your advice? What is your advice to them as they're starting out on their new administration? What's the biggest impact action they can take as a government?
So we set out 10, but highlighted 10 recommendations, which I'm not going to remember all 10 just now.
Give me one of them.
So one of them was sorting out the pricing of electricity. So that's important as an incentive to go for electrified heat and to electrify industry, rather than using gas. So we believe there are imbalances in that at the moment. So, for example, there were costs of getting the renewable sector going back sort of 10, 15 years ago, where the technologies were more expensive than using fossil fuels at that time. So to the market, they represented a cost. So they had a subsidy in effect. And that subsidy is being paid back through electricity bills. So we suggest that it would be actually a good idea to encourage the good stuff, using electricity, low carbon electricity, and discourage the bad stuff.
So make it more expensive to use gas, essentially, or carbon emitting.
Make it more expensive to use fossil fuels and less expensive to use electricity.
And how would you do that?
So one thing is by rebalancing across bills, but another way could be to take those legacy costs out of bills and put them into general taxation in some way. So there is a problem, of course, if you take it out of one part of the bill and put it onto another, what's the net effect? And who's most impacted by that? So we've got to be careful that people who are already in fuel poverty are not taken into further fuel poverty because their net energy bills goes up because, it's depending on the proportions of how much electricity you use versus how much gas or petrol or whatever you use. So we've got to do it a bit carefully. But the net result that we want to see is that electricity bills are reduced. And there's another way in which that could be done, which is through reform of the wholesale market so that it better reflects the cost of electricity today, with the average cost, which a lot of it is coming from renewables, and the new renewables are really cheap. But when you've got a market that's, let's say, entirely set by the marginal price of, and that's set by the marginal price of gas, and when gas is very expensive, it looks like, that price is higher than the average price of production. So how can markets be designed such that you've still got the incentives to investment in new capacity, but the sort of low average cost is sort of passed through to consumers. They can kind of benefit from that.
Let me interrupt for just one more second. What do you think? Give us your views. We're all learning as we go through the clean energy revolution. Leave your comments, give us a like, or share with one of your colleagues. What do you say to people who look at this issue and say, God, it's bloody so difficult? And what's the point there? It's going to cost too much. And what's the point anyway? The UK is just one country out of many, and other countries are building more coal plants. And, what's the point? How do you respond as an energy expert?
So firstly, I think in the long run, this will be cheaper, actually. So, renewables are cheap. Even if you look at the average system cost, so people quite rightly say, well, what about when it's not windy and sunny? So some analysis, I mentioned earlier, a report by the CCC published in March last year. So that suggests that this average system cost in 2030, including for hydrogen facilities and so on, would be lower than the average wholesale cost of electricity last year. So, hey, that's worth having, isn't it? But at the same time, though, there is a capital cost. There's an upfront cost to this, which cannot be denied. Heat pumps are expensive to install. We might need to replace the radiators or the pipework, and we want to improve the insulation. Electric vehicles, cut them off the forecourt, they're expensive, even if the energy that you put into them is cheap relative to fossil fuels. So, like I say, it's cheaper over the long run, but in the short run, there is that capital cost to be faced. So how do we deal with that? What systems of loans or grants can we put in place to help navigate it? And how can we make it easier, navigate the disruption that comes along with it as well? And then our international dimension. Yeah, you're right. We're just one small country. We're kind of relatively small emitter, certainly in comparison with China, the US, India, and so on. But I think it is true that we sort of punch above our weight in terms of influence. I mean, this is a classic thing, isn't it? About Great Britain, and we still think we've got an empire. Well, avoid getting into a debate about whether we should have an empire in the first place, but we haven't got anything like that kind of influence that we had in the past. It's all gone, quite rightly, but there is still a thing where we are one of the first industrialized nation. There is a big challenge that we've got in decarbonising our economy. We've gone a long way there, as we were talking about earlier, so we can show that it can be done. We can set an example there. And if we stick to our commitments about doing the rest of it, then we have seen that other countries have kind of come along with us. The European Union setting targets, the US, the Inflation Reduction Act had lots of things built into that. See how well that sticks. In China, they've committed to net zero, I think, by 2060. It'd be nice if it was a bit earlier. But the Chinese government, again, there's a big debate about the means that they use, but they tend to deliver what they've promised to deliver. And it's in their own interest to deliver. They're affected, many parts of their country are affected by climate change much more even than we are here. But if we don't do it, it's very hard to talk to these other countries and say, well, you've got to do it. So, I think that kind of international leadership is really important. And when we had the COP that came to Glasgow in 2021, wasn't it, in November, that leadership really worked, I think, in kind of corralling various countries around not just the kind of main Glasgow Pact, but also of various side agreements around it.
So you're an energy optimist?
Yeah, absolutely. Yeah, definitely. Like I say, we've achieved a lot already. I mean, this is where I think it gets difficult. Okay, so we've achieved a lot in terms of the electricity system. That's only part of the whole energy system. And what we've achieved so far, unless you're someone who's living in view of a wind farm, basically we've done it without anyone noticing. It's on the production side. We still use electricity in whatever way we always did. The difficult bit is when everybody notices, like when we have to replace a heating system or the way we get around. So there is a challenge of bringing everyone with us and showing that it can be done. But I believe absolutely it can be done. Again, the sort of heating systems you can look around the world and see they are used in other places. And most people who I know who've got an electric vehicle absolutely love it and wouldn't go back, So it's an attractive product.
Keith Bell, thank you very much.
You're welcome.
And that's all we have time for this episode. As ever, if you can, please like, share or comment below, as it helps spread the word about the podcast and the information in each of our episodes. But from all of us here, thanks very much and see you soon.